Sent to me as a doubt by a student from YouTube. The question is a perfectly reflecting mirror of mass m. The mirror is having the mass capital M, mounted on a spring, constitutes a spring mass system of angular frequency is this. The angular frequency is given to me. What is this? Angular frequency is given as this. This is omega. H into 10 power 24 divided by 4 pi capital M. Okay. This is okay. H is Planck constant. N photons of wavelength. This strike the mirror simultaneously at normal incidence such that the mirror gets displaced by 1 micrometer. Okay. Means the maximum displacement that the mirror gets, they have given it to be 1 micrometer. Okay. 1 micrometer. Okay. And this would be the amplitude. If the value of n is this, then the value of x is what? It means in short, they are asking the what is the value of n, where n is the number of photons. Let me solve it for you. See, in this question, k is not given, so that means the use of law of conservation of energy is out of question. We cannot use it here. One thing, because the photons are given, their wavelength is given to me, so I can use if there are n photons which are striking. See, for one photon, lambda is equal to, we can write h by mv. Okay, these are photons which are striking. Now for n photons, mv will be h by lambda if they are having velocity just before the collision. Each photon, this is for each photon. So for n photon, the momentum will be nh by lambda. But again, see, they have not said that the photons after striking, they are not coming back. They are coming back because they did not say that these photons are getting absorbed on this mirror surface. They are getting attached. They did not say this. So we have to apply mv minus mu, and since the velocity is not changing with the velocity with which they are striking, the same velocity they are coming back, to the force the velocity with which this mirror will be getting, we can apply 2 mv wait. The momentum transferred to this will be, the force transferred to this will be 2 mv, which will be 2 nh by lambda. because we know na impulse is equal to mv minus mu. In this case it will be n into mv plus n into mv, so it will be 2n mv. This is the impulse transferred f delta t, and because of this impulse, this starts to move with certain velocity. Say now this f delta t is equal to m into velocity v naught. So I can easily apply 2nh by lambda is equal to mass of the mirror into its velocity that it acquires after the collision of the mm, photons. So the velocity of the mirror after the collision became v naught is equal to 2nh by capital M lambda. Now this is the velocity that this mirror is getting, or this, see I have done this one. If you do not apply the law of this impulse method, you can just do the law of conservation of momentum. The initial momentum is mv of the photon, final momentum is capital M into v naught minus m into v, so 2mv is equal to capital M into v naught. Like that you can do also, that's not a problem. And since n photons are striking, you have to multiply n to this, 2n mv, nmv, nmv, nmv is equal to mv naught. So like this, so 2n into mv is equal to capital mv naught. Like that also you can do, where mv you can put as h by lambda. This what I have done is law of conservation of momentum. This also you can do, that's much better, because many of the students they know how applying the law of conservation of momentum in the case of collision rather than impulse. So v naught we have found actually, but because they have said after the collision this mirror moves by a distance of 1 micrometer, means this has to be its amplitude. So that means v naught should be equal to, and this position from where it has started, it is relaxed position. So at this position, uh, this position is still relaxed position, so at this position this is a mean position, so at this the velocity will be maximum. And according to shm we know the maximum velocity is given by its a into omega, where a is 1 micrometer. 2, so the equation becomes 2nh by m into lambda is equal to the amplitude, which is 1 micrometer, 1 into 10 power minus 6, into the omega angular velocity, which they have given h into 10 power 24 divided by 4 pi capital M. Now comes the solving part. M is cancelling with M, H is getting cancelled with H, so the value of N is 10 power 18 by 8 pi lambda value is also there. What lambda value they have given? 8 pi into 10 power minus 6. Array, it has become very easy. 8 pi into 10 power minus 6. So the value of n that you should get is 10 power 12. N is equal to 1 into 10 power 12, and they have given it is equal to x into 10 power 12 So x value is 1 here. This should be your answer. This was actually easy question.